Hello everyone and welcome to the Chapter 11 Let There Be Light overview from the John Gribben book, The Scientist. The major discoveries in this chapter will be regarding light, electricity, and motors. Just a couple points here. Remember from these chapters on, from chapters 11, 12, 13, and 14, you're going to read specific pages. And for this chapter, Chapter 11, I'd like you to read from page 400 to 424. The scientists that we'd like you to focus on are Thomas Young, the double-slit experiment, Joseph von Fraunhofer, and William Wollaston, and the discovery of dark lines in the spectra for the sun. As you'll figure out, Wollaston was the first one to discover these dark lines, and but why was Fraunhofer given the credit? And finally in this chapter, Michael Faraday and his studies of electromagnetism and the electric motor. So let's get started. One of the first scientists that you'll read about in the nature of light is Thomas Young. And before Young, Newton, when he thought about light, he put out that light was really composed of particles. He thought it was made of particles. Newton was wrong, and one of the first experiments that proved that was Thomas Young's experiment in 1805 that proved that the wave nature of light by observing a phenomena called interference. We have a couple diagrams to show you. This is the overhead view of his double-slit experiment. You'll see that sunlight is coming in from the top. We're actually looking down on this experiment through one single slit. That slit, that light, as it came through, then goes through two slits, and what Young found was that there were dark lines caused by interference of the waves. You'll read more about it. It's really a huge discovery in the nature of light. This is an actual picture from one of the experiments. That's the single slit pattern, but then you'll see the double slit pattern caused by interference. The next person we'd like you to take a look at is Joseph von Fraunhofer. Fraunhofer was celebrated in his country by this stamp, and you'll notice in this picture, this portrait of Fraunhofer, that he has an elegant brass scientific instrument there, and that instrument is a spectroscope, because one of the things that Fraunhofer did was take a look at the light of the sun. Here's one of his instruments. This is a spectroscope. And what he discovered was that there were dark lines in the sunlight that was coming in and passed through that prism. It's a fascinating read. The dark lines are from cooler gas absorbing radiation behind a star such as the sun. But this is the really amazing part, is by seeing what wavelengths are absorbed, scientists could tell what elements are in the gas. Now think of that. From 93 million miles away, we can analyze light now and see that it's primarily made, in this case sunlight, is primarily made of hydrogen and helium. A fantastic discovery, and you'll read why Fraunhofer was given the credit over Wollaston. Another scientist that I would like you to read, and I think Gribben does a wonderful job of putting Michael Faraday in the social context of his time. Faraday was an amazing, amazing scientist, and lots of the instruments and machines that would follow in the Industrial Revolution got their start with Michael Faraday. Here's Michael Faraday on the 20-pound note. I want you to note a couple things. I blew this picture up really large because I want you to take a look at a couple things here. On the left-hand side, Faraday is giving a lecture. One of the things that he was very, very famous for was his ability to explain complex ideas to lots of people. And this ability really allowed his inventions, his observations, to reach a broader public and actually sped their application through inventions of technology. He's really given an awful lot of credit. Here he is at the Royal Institution Christmas Lectures, which were initiated in 1826 by Faraday, and his magneto-electric spark apparatus. That's in the lower left there with handles to turn it to create the electric spark, which was a huge sensation in the day. He was famous for finding out how electric motors work. This is his induction apparatus. You'll read more about that. Just a couple course notes before we end, and that's please continue to contribute your research to the Google Plus community. This is important. I put out an email about that earlier in the week. Please do that. And besides reading the chapter sections in our text, please start to prepare and plan for paper number 2 for the course. Consult our Blackboard site for a full description of the paper. Hope you enjoy this chapter, and I'll see you next week, or you'll hear from me next week.